Hi guys, this is a quick follow-up tutorial to the tutorial on how to perform tests for differences between two independent groups of samples, in which I'm just going to quickly show you how to create the appropriate graphs for those tests. Now this is the same data set that's been used in the other tutorial, so if you want to know more about it, then I'd recommend you watch that video. And you should watch it in any case in order to understand the differences between those tests. Now there are two tests for differences between independent samples. One is the independent samples t-test, which is parametric. That means the data have to be normally distributed and it uses means and standard errors in order to compare measurements between these two groups of independent samples. The other one is the Mann-Whitney U-test, which is non-parametric, and that means the data don't have to be normally distributed and it uses medians and ranks in order to compare these measurements. Now, in accordance with that, the appropriate graph for these two tests is different. Now, for the t-test, where we've used means, the best graph to produce would be a bar chart with error bars that represent the standard error, and for the Mann-Whitney test, it would be a box plot because that represents the median and interquartile range in terms of ranks. And so I will just briefly show you how to produce both of those graphs when you have independent data such as we have here. We'll create those graphs for height and not foot size, and we will create that for both male and female, or in a comparison between male and female subjects in this test. So both of those graphs are created through the chart builder, which is in graphs. It always comes up with this dialog box, which just asks you whether you are sure that you set all of the variables up correctly, which in this case we have, so we can click OK. If you haven't, then you can define the properties here. What you first have to do is to decide which graph you want to make. Now, if you have done a t-test, an independent samples t-test, to look for differences in body height between male and female subjects, then the correct graph to use would be a bar chart. And in order to make that, you just drag this simple bar symbol into your preview, which is this one here. And then what we need to do is to just explain to SPSS what our different bars should represent, and that should be our independent variable, which is in this case sex, male and female. So that goes on the x-axis, okay? And then we want to just specify which measurement we want to compare. In this case, that's body weight. And that's exactly what this is going to do. Then the last thing we then need to do in order to create this graph is to show the dispersion as well as the central tendency, because we should always do that. In this case, we have the central tendency of the mean, and that goes in case of the t-test with the standard error. Now, in order to display that as an error bar, we need to be sure that we're in element properties over here, and we have bar 1 selected, which is these bars here. And then we specify that for those bars, we want to display the error bars. And specifically, we want those error bars to show the standard error of the mean, okay? That's because the t-test uses the standard error of the mean. It doesn't use the standard deviation. The standard error of the mean is a derivative of the standard deviation, but it takes into account population size, or at least it estimates population size. Now the default setting here is for the multiplier to be set to 2, which is not what we want. We want to show the error bars in form of 1 standard error around the mean. And that's all we need to do in order to make this graph. So once we've done that, we can click OK, and then the graph will appear in our output file. Okay, so this is the mean of body height in centimeters by sex, which is our independent variable. This graph is pretty much ready. The only thing is that normally we wouldn't say that the body height is in mean. We would actually specify that in our figure caption. Now, in order to change anything in this graph, we can double click it in order to activate the chart editor. And now we can make all sorts of changes from the color of the bars to what it says on the axes. I would then change this axis here to just say body weight, and I would specify in my figure caption that this chart shows the mean and standard error. And then I would also usually get rid of this title. In order to change any of these, the axes or the titles, you basically just have to select them once with a click and then wait a second or so and then click them again instead of double clicking. And that way you can just delete or change whatever you like in there. That's all we need to do here. So basically we can just close this window, and then whatever changes we've made will be represented in our output file in this graph, and then you can go on to export this or copy it into your reports. Now, if I just quickly go back to our data file, this graph that I've just created would be appropriate if we had used an independent samples t-test to analyze the differences in body height between male and female subjects. That would only be possible if our data were normally distributed. Now, if our data were not normally distributed, we would have to create, we would have to compare this measurement between the two groups using a non-parametric test, which is the Mann-Whitney U-test. Now, that doesn't use means and standard errors, it uses medians and ranks, and that's why we would not create a bar chart, because that shows means. We would instead create a box plot. Because that shows medians and ranks. It is made through exactly the same pathway. So we go back into graphs, chart builder, we confirm that we have set everything up correctly. And then instead of the bar chart, we actually take the box plot and we drag that in here. Okay, because we've made this before, everything else is actually still set. We don't need to display any error bars, and it actually doesn't give us that option here, because these are in a box plot there by default. Okay, as a reminder, the box plot shows the median as the big thick line here in the middle of the box. The height of this box, the distance between these 2 points here, represents the interquartile range, and then we have the range, so the minimum and maximum of these values in the whiskers. That's all we need to do for this. We can just press OK, and it will create this box plot for us. As before, if we want to make any changes, we double click. We can, for example, delete this title here because we don't normally have a title. Instead, we would specify what is shown in the graph in the figure caption. Everything else is just fine in this case. Okay, and then if we close it, any changes we've made are represented here in the output file. Okay, so this is how to create graphs for independent samples, and I recommend that if you haven't watched it yet, you also look at the test for differences for two related samples, and also there is an associated video that explains how to create graphs for those, because that works slightly differently compared to what we have here, which is independent samples.